Greetings everyone, and welcome to SpaceWeek Live for Sunday, July 11th, 2021. So here we are once again, and hot off the heels of a very cool live stream earlier today. But yeah, let's get right into it. Last week, what happened? We had a bunch of Chinese launches and a couple other things. Let me switch to my, there we go. Oh yes, instructions before we do that. As always, this is a live Q&A session, so if you have any questions for me, go ahead and put them down in the chat, and make sure to tag my name, Ross Space, so that we're sure to see the questions highlighted, and I will address them at the end once I've done with my presentation. Thank you. So last Sunday, a Chinese Long March 4C rocket launched the Fengyun 3E meteorological satellite from remote Jiuquan Satellite Launch Center in the northwest of China. And once again, those white panels you see falling off of the payload fairing at the top of the rocket are not ice. They are insulation panels that protect the payload from the ups and downs of the weather and the temperature. And they are designed to fall off during launch. Then on Tuesday, a Chinese Long March 4C rocket, a Long March 3C launched the Tianlian 1-5 communications satellite from Zishang Satellite Launch Center. some brief video there from that one. Then on Thursday, Thursday, the SpaceX Dragon 2 CRS-22 cargo spacecraft undocked from the International Space Station, and I believe it was 2 days later it deorbited. No, I'm sorry, it was a day and a half. I think it was a day and a half later. In any case, a while later it deorbited. They don't show the deorbit in any kind of live broadcast because it's just a cargo craft. But yeah, and it splashed down successfully in, I think, the Gulf of Mexico, off the coast of Florida. Unfortunately, they had some unfortunately timed handoffs with the video uplink from the ISS, and so we didn't actually get to see the undocking when it happened. And additionally, they didn't actually even have any sweet Earth views during the broadcast. I think, well, I could look it up, but I'm wondering if maybe the Dragon had been docked to a zenith port facing away from the Earth versus a nadir port on the Earth side of the station. Therefore, once it undocked, we wouldn't be seeing the Earth, we would be seeing the blackness of space behind it. And of course the absence of stars, because the camera exposure is set for the brightly lit Dragon cargo spacecraft. Then on Friday, yet another Chinese launch, a Long March 6, carried the Zhongzi 2 satellite group to orbit from Taiyuan Satellite Launch Center. Finally, the big news of the week. This morning, today, Sunday, 7-Eleven, get your big gulps, because Virgin Galactic made history with their first fully crewed suborbital spaceflight. They've flown to space a few times before, but never with a full crew. So today, 2 pilots and 4 other Virgin Galactic passengers, including company founder and charismatic billionaire 70-year-old Sir Richard Branson, rode in their scaled composites Spaceship Two spaceplane VSS Unity, which was mounted under the wing of the White Knight II carrier aircraft VMS Eve, named after Branson's mother. They took off from Virgin Galactic's Spaceport America facility near White Sands, New Mexico, where I've been, and it's an amazing place, and flew to an altitude of about 15 kilometers or 49,000 feet. VSS Unity was released from the carrier plane, its hybrid polymer-fueled engine ignited, and it completed a full burn. Its momentum continued to carry it to an apogee of about 86 kilometers or 53 miles, at which point it ballistically arced back down into the atmosphere and glided gracefully to a landing back on the Spaceport America runway. Let's check out the release and ascent of Unity 22 mission.
We are armed for release. 20 seconds. 10 seconds. 5, 3, 2, 1. Release, release, release. Clean release. Ignition. Good rocket motor burn. There's Mach 1 trimming now. Trim complete. Unity is pointed directly up and heading to space. Things are looking great. We are 25 seconds into the burn now, approaching Mach 2. 30 seconds, Mach 2. Everything's looking really good and stable. 40 seconds. 45 seconds. 50 seconds, approaching Mach 3. There's Mach 3. And 60 seconds, and that is a full duration burn, folks. We are headed to space.
So once the engine stops firing, the craft it continues to ascend due to its momentum, and so I had thought that their target altitude was 110 kilometers, but it apparently was not. It was only 86 kilometers. But there was some debate in the live stream chat about whether they actually reached space. So I figured I would provide some explanation here. So Earth's atmosphere, as you may know, has a pressure gradient from 1 bar of pressure at sea level, or 14.7 psi, to 0 bar in space. There is no natural, hard, and clear line that defines the edge of space. So we humans have to agree upon an imaginary arbitrary line for regulatory and legal reasons. Back in the mid-20th century, Hungarian-American engineer, physicist, and mathematician Theodor von Karman calculated that the altitude at which aeronautical flight is no longer possible due to insufficient atmospheric pressure is 83.8 kilometers or 52.1 miles. I'm sorry if I mispronounce this. I'm terrible with French words, but the Swiss-based Fédération Aéronautique Internationale, or FAI, which is actually called the World Air Sports Federation in English, and is not to be confused with the Paris-based International Astronomical Federation, which is very confusing, is the world governing body for air sports, and interestingly, also codifying the definitions regarding human spaceflight. They set the boundary of space at 100 kilometers, or 62 miles above sea level, naming it the Kármán line after Theodor von Karman. In the United States, though, NASA, the U.S. Space Force, Air Force, and the Federal Aviation Administration define the boundary of space as 80 kilometers, or 50 miles above sea level. Much closer to Theodor von Karman's calculation. So if you fly above 80 kilometers, according to U.S. authorities, you can be called an astronaut, and you have earned your astronaut wings. Therefore, Sir Richard Branson is now not only a knight, but he is also an astronaut. Pretty cool. So congratulations to Virgin Galactic. That is great news and a big positive step toward the toward space tourism and the commercialization of space in such a way that common folk such as you and I can actually enjoy it eventually. So looking ahead to you pesky thing. Looking ahead to this week, there actually aren't any launches or other live events on the schedule, though we do have a couple items of note. On Wednesday, July 14th, the planet Jupiter will be in opposition, meaning it will be located on the opposite side of Earth from the Sun, and it will look particularly bright. It's probably pretty bright right now, but the official date of opposition is July 14th. It should rise above your horizon around 11 p.m. in the constellation of Aquarius, if you know where that is. Then on Friday, July 16th, we have the 52nd anniversary of the launch of the Apollo 11 mission to land humans on the moon for the first time. They launched on the 16th, they landed on the 20th, and then they returned on the 24th. So, there you go. Let me go, and that's it for this week. It's a pretty quiet week. So let me get to your questions. Do we have any this week? Real Sven Gaming. Raw Space, what type of gas do Long March rockets use? Well, there are different models, just like, I mean, basically China calls all of their government rockets Long March of one sort or another. So there's, I mean, not all of them, but most of them. So the ones I mentioned, I can look these up real quick. Oh, golly. Misspelled it. All right. The ones I mentioned are the Long March 4C. Long March 4C, first stage uses hypergolics, dinitrogen tetroxide or nitrogen tetroxide, and UDMH or unsymmetrical dimethylhydrazine. The Long March 3C the boosters are also hypergolic with the same nitrogen tetroxide UDMH mixture, and the first stage is hypergolic as well. China uses a lot of hypergolics. The Long March 6 is first stage uses RP1 or refined kerosene and LOX, just like Falcon 9 and the Saturn V. So different Long March variants use different fuels. All right. Real Sven Gaming asks, hypergolic? Hypergolic fuels are binary fuels. They are stable until you mix them, and then they become highly combustible. So if you take, I mean, they're toxic as all get out, but so you don't want to breathe them. But I mean, you take the nitrogen tetroxide, it doesn't combust. You take the UDMH, it doesn't combust. But you combine them together, and you get a very effective propellant. So that's simply the hypergolic. The word, as a matter of fact, the definition of hypergolic is, definition. Igniting spontaneously on mixing with another substance. There you go. All right. Any other questions that didn't make it into... Nope. Yeah, Rockin' Robin's 13. Sir Richard Branson did indeed beat Jeff Bezos to the punch. So, Virgin Galactic was founded 15 years ago, back in 2004. And Blue Origin is similarly old. They were, I think Blue Origin was founded in the mid 2000s as well, early to mid 2000s, and both had their sights set on space tourism, suborbital commercial flights for paying customers, and. But yes, they've both had a long road, but Sir Richard Branson did beat Jeff Bezos. Now Bezos' turn is coming soon. I didn't cover it in this episode because it's going to be next week, but Blue Origin's first manned spaceflight, or first crewed spaceflight of their new Shepard rocket will be on the 20th, July 20th. Next week, but I'll say more about that in the next episode, next Sunday. Let's see. Elmo Jones Music Orpheum asks, could you talk about the problems with Hubble and the possible fixes? Unfortunately, I am not well versed in the current Hubble woes. I've been pulled in a bunch of different directions lately, and I haven't had the opportunity to read up on what's going on. I've heard that the Hubble has maybe on its last legs, and I don't know if it was the maybe the final reaction wheel that went out, or whatever, that would prevent them from aiming the telescope, or what the problem is. But so unfortunately I don't have details for you on that. I know a reasonable amount about a lot of different things, but my knowledge is neither encyclopedic nor necessarily up to the minute, because I'm just a human. So we do not currently have a craft that is capable of, well, maybe Crew Dragon could do it. I don't know. A Hubble rescue mission, a Hubble repair mission. Crew Dragon was designed for orbital flight, for docking with the ISS. Its mating adapter is specifically designed for compatibility with the ISS, but I suppose they could match Hubble's orbit and send a mission to do a repair if it came to that. I mean, that would be better than spending umpteen $1 billion and taking 20 years to launch a new Hubble. I mean, it's been that long, and we still don't have James Webb, and that's not even an optical telescope; it's infrared. So, yeah, I should read up on what's going on with Hubble, because, I mean, it's a unique and invaluable resource for astronomical study. But it is quite old at this point, and I think we're lucky that it's lasted this long. Okay, I think that'll wrap it up for this week. Thank you all for coming. Again, it's going to be a quiet week ahead, but that is okay. We get a bit of a break, and yeah. So enjoy your summer. Don't get too hot. Stay cool. Keep it raw, and I will see y'all next time.